Friends, welcome to my YouTube channel. Dhanesh here. Today we are going to discuss about one of the important concept you need to understand about regression models, whether it is linear regression or logistic regression, that is R squared and adjusted R squared. We see there is videos about what is R squared, all those aspects. It's we discussed. You can see it in the playlist. But what is the importance of this adjusted R squared in regression model? Why we are going for adjusted R squared? What is the drawback or what is the limitation of R squared? So that's what we are going to discuss today. Let me give a quick recap of correlation coefficient, that is R. The correlation coefficient is a statistical measure of the strength of the relationship between two variables. You know, this is the fundamental concept when we talk about y is equal to mx plus c. This is the y is the dependent variable, you know, x is the independent variable, that you know, where m is the slope and c is the y-intercept. You know about these aspects. Here x is, we call it as, see, this equation we can rewrite it as y is equal to m1 x1 plus m2 x2 plus m3 x3 plus etc plus c, like this. Here x1 x2 x3 you can call it as the features. This independent variables you can call it as features. Independent variables or features, you are familiar with these aspects. And y is the output, that is the target variable. The dependent variable you call it as the target variable, the output. All these things you are familiar. Now the correlation coefficient, it is a statistical measure of the strength of the relationship between the dependent variable and the independent variable. The value ranged between minus 1.0 and 1.0. A calculated number greater than 1.0 or less than minus 1.0 means that there was an error in the correlation measurement. It's usually known as Pearson correlation. This is a positive correlation. We discussed this is a negative correlation. That means R is equal to minus 1. Here there is no correlation. It's already discussed. This is the equation for correlation coefficient or Pearson correlation coefficient. This is covariance. And this is the standard deviation. Sigma is the standard deviation. You can watch these videos. See, covariance and standard deviation we discussed. Covariance is the measure, the degree in which two variables are linearly related, and standard deviation is the measure of the spread of data. We discussed all these aspects. Here I am mainly focusing on R squared and adjusted R squared. See, what is the drawback of R squared and why we are going with adjusted R squared? See, R squared explains the degree to which your input variables explains the variation of your output variable. Input variable means the features x, x1, x2, x3 that we discussed. Output variable means y. So if R square is 0.8, this is very important. If R square, if you are getting 0.8, it means 80% of the variation in the output variable is explained by the input variable. This is really important. So in simple terms, higher the R squared, the more variation is explained by your input variable, and hence it is a better model. See, higher the value of R squared, your model is good. That's what from this we can understand. But we will again discuss this point. It's not correct actually. Why it is, we will discuss. R squared is a statistical measure of how close the data are to the fitted regression line. It's also known as the coefficient of determination or the coefficient of multiple determination for multiple regression. It is the percentage of the response variable variation that is explained by the linear model. This is the formula for R square. Variance explained by the model divided by total variance. R square means it is the variance explained by your machine learning model divided by the total variance. R squared is always between 0 and 100%, or it is between 0 and 1. R is always between -1 and 1. We discussed. 0% indicates that the model explains none of the variability of the response data around its mean. 100% indicates that the model, 100% means it's 1, indicates that the model explains all the variability of the response data around its mean. In general, the higher the R squared, the better the model fits your data. This is important. A high R square value is good. That means the model is, model fits your data very well. But what are all the limitations of R squared? That's what this is very important. R square is a basic matrix which tells you about that how much variance is being explained by the model. What happens in a multivariate linear regression if you have multiple variables? Like I told you, you have y is equal to mx plus c. In this equation, you have only one feature, only one input, right? But when your equation becomes y is equal to m1x1 plus m2x2 plus m3x3, like that, you have many input features. Some of the features can be very significant and some are not significant as well. In that case, what will be the case of the value of R squared? See what happens in a multivariate linear regression where you keep on adding new variables, the R square value will always increase irrespective of the variable significance. When you increase the variables, this x1, x2, x3, the R square value will increase. R square cannot determine whether the coefficient estimates and predictions are biased, which is why you must assess the residual plots. So I am planning to create separate videos for this as well, so you need to understand residual plots. R square does not indicate whether a regression model is adequate. You can have a low R squared value for a good model or a high R squared value for model that does not fit the model. This is very important. So this is the limitation of R squared. So R squared versus adjusted R squared. So R square is a basic matrix which tells you about that how much variance is being explained by the model. What happens in a multivariate linear regression? If you keep on adding new variables, the R square value will always increase irrespective of the variable significance. Even though the features you are adding are insignificant, the value of R squared increases. What adjusted R square do is calculate R square from only those variables whose addition in the model which are significant. This is very important. That is the importance of adjusted R square. So always while doing a multivariate linear regression, we should look at the adjusted R square instead of R square. If you have multivariables, multivariate regression model, then you should go for adjusted R square instead of R square. Very important. R square, again we are continuing as discussed. The problem with R square is that it will either stay the same or increase with addition of more variables even if they do not have any relationship with the output variables. This is where adjusted R square comes to help. Adjusted R square penalizes you for adding variables which do not improve your existing model. If you are building linear regression on multiple variables, it's always suggested that you use adjusted R square to judge goodness of model. In case you only have one input variable, R square and adjusted R square will be same. If you have only one input variable, only one feature. Typically, the more non-significant variables you add into the model, the gap in R square and adjusted R square increases. It's very clear. We explained it properly. Formula for R square and adjusted R square. This formula we already discussed. R square is the variance explained by the model to the total variance. This is the another equation for R square, 1 minus RSS divided by TSS. This is the equation for R square adjusted, it is 1 minus R square into n minus m by n minus m minus 1. See, what is this RSS, TSS? RSS is the sum of squares of residuals from regression model. This is RSS, sum of squares of residuals from the regression model. TSS, the total sum of squares of errors from the regression, from the average model. N is the number of rows or the total sample size. In the equation, this N and M, this is R. This R only we are substituting here. See, what is N? N is the total number of rows or total sample size. M is the number of columns or number of predictors or number of variables in your model, the number of features in your model, that is M. N is the total sample size. As the number of features increases, the value in the denominator decreases for adjusted R squared. So how it happens? See, adjusted R square, how it penalizes you. R square assumes that every single variable explains the variation in the dependent variable, but the adjusted R square tells you the percentage of variation explained by only the independent variable that actually affect the dependent variables. Very important. We already discussed this point. The adjusted R square will penalize you for adding independent variables. That is m in the equation. Independent variables means it is the features. The number of independent variables means m in the equation. We already discussed that do not fit the model. In regression analysis, it can be tempting to add more variables to the data as you think of them. Some of these variables will be significant, but you can't be sure that that significance is just by chance. The adjusted R square will compensate for this by penalizing you for those extra variables. So this m, that is the independent variables in your, that's the features in your equation. So the adjusted R square will penalize you for adding the independent variable based on this equation. This is the equation. In this equation, this m is the the additional features. You are getting me? See, these additional features, when you increases this will, this term, actually this term will decrease. When this decreases, again this will increase, then 1 minus that term will, actually adjusted R square decreases. You are getting my explanation? See, m, what is n? N is the total sample size. What is m? M is the number of features. When you are number of features, the input variables, x1, x2, x3, that is m. As this m increases, this term, the denominator, decreases. So this term increases. So 1 minus this term again decreases. So adjusted R square won't increase as you increase the number of features like R square. When you increase the number of features, R square will increase. So this is the concept of adjusted R square. So it penalizes you. The adjusted R square will penalize you for adding independent variables m in the equation that do not fit the model. In regression analysis, it can be tempting to add more variables. So that's all about R square and adjusted R square. Thanks for watching. Please like, share and subscribe. Thanks a lot.